All right, let's dive in. We're going to talk about a language that honestly is quietly running pretty much everything from behind the scenes. It's called C. And you might not think about it, but from your computer's operating system to like your microwave, there's a very good chance C is in there somewhere. So, here's the big question. How is a language that was born back in the 1970s still running our super modern world? Let's find out.
So, right off the bat, we've got a major problem. See, we think in ideas and words, right? We think something like, hey, computer, just print hello world on the screen. But computers, well, they don't speak English. They speak this, a long, basically infinite-looking string of ones and zeros. That's machine code. So how on earth do you bridge that gap? How do you get from our idea to their language?
Okay, so here's our game plan for breaking this all down. First, we're going to tackle that human-computer gap. Then, we'll meet the amazing tool that acts as a translator. After that, we'll actually take apart a real program to see what makes it tick. We'll look at how programs can make decisions, and then wrap it all up by understanding why C is still, even today, so incredibly important. And that's exactly where a programming language like C comes into play. You see, C is what we call a high-level language, which is just a fancy way of saying it's designed to be readable by us, by humans. But to actually make that jump from our words to the machine's ones and zeros, we need a special kind of translator. And that brings us to the first really crucial piece of the puzzle.
That tool is the compiler. I want you to just think of it as a master translator. It has one and only one job. Take the code we wrote in C, the human-friendly stuff, and translate it perfectly into that super strict ones and zeros machine code that the computer's processor can actually understand and execute. No compiler, no program. It's that simple.
And you know, the whole process is actually pretty straightforward when you break it down. Step 1, we write our instructions in a plain old text file. That's what we call our source code. Step 2, we feed that source code to the compiler. And finally, step 3, the compiler does its magic and spits out a brand new file, an executable. That is the program our computer can actually launch and run. Okay, enough theory. Let's get our hands dirty and actually look at some code. We're going to dissect the most classic, the most famous first program that pretty much every single programmer in history has written, Hello World. Yeah, look, I get it. This might look a little intimidating. You've got hashtags, brackets, parentheses, weird words, but I promise you, every single piece of this has a very specific and clear purpose. So let's break it down, one piece at a time, starting with the most important part. So, at the very heart of every single C program, you're going to find this, the main function. Think of it like the starting line in a race. It's the first place the computer looks. It finds main, and then it just runs whatever code is inside those curly brackets. Simple as that. And what do we have inside? Well, a command called printf. That's just a built-in C function, and it basically just means print this text to the screen. Now, to even use cool built-in tools like printf, we have to tell the program where to find them. And that's exactly what that very first line does. Hashtag include standard library of tools is us telling the compiler, hey, go grab the standard library of tools because we're going to need them.
And what about that little semicolon at the end? You know, it's actually super simple. Just think of it like a period at the end of a sentence in English. It's how we tell the compiler, okay, this command is done, finished. You can move on to the next one now. It seems like a tiny detail, but it's an absolutely critical piece of punctuation. Without it, the compiler has no idea where one instruction ends and the next one begins.
So we know how to give the computer a command, but how do we get our programs to remember stuff? I mean, we can't just type numbers and text directly into our code for everything. For that, we use something called variables. And the best way to think of a variable is just as a named box in the computer's memory. It's a little container where we can store a piece of data, say a student's grade or a user's name, and then we can just refer to it by its name whenever we need it later.
But here's the thing. Just having a program run a list of commands, one after another, isn't really that powerful, is it? To do anything truly useful, our programs need to be able to make decisions. They need to be able to repeat actions. This whole idea is what programmers call controlling the flow.
So the most basic way we can make a decision in code is with an if-else statement. It is literally like a fork in the road for your program. The code gets to a point and checks a condition. For example, is the grade greater than or equal to 50? If the answer is yes, if that's true, it goes down one path. But if it's false, it follows the other path. Simple as that.
Okay, so making choices is cool. We can go left or right. But what happens when we need to do something 100 times or maybe 1,000 times? Surely we don't have to copy and paste the same lines of code over and over and over again, right? There has to be a better way.
And of course there is.
We use something called a loop. A loop is just a structure that tells the computer, hey, see this block of code? I want you to repeat it over and over again, as long as this one specific condition is true. Honestly, this is the absolute key to automation in all of programming. Now here's where it gets really clever. How do we stop the loop from running forever? Well, we use a counter. Let's say we start a counter variable I at 0. The code asks, is I less than 3? Well, 0 is less than 3, so yep, the code runs, and then we add 1 to the counter. Now I is 1. Is 1 less than 3? Yep, run the code, add 1 again. Now I is 2. Is 2 less than 3? Still yes. Run the code, add 1 again. Now I is 3. The code asks one last time, is 3 less than 3? Nope, it's not. And just like that, the condition is false, and the loop stops. It terminates precisely when we want it to. This super simple mechanism, it's the engine that drives automation in pretty much all of programming.
Okay, so we've seen the fundamental building blocks, right? We've got variables to store stuff, if statements to make choices, and loops to repeat things. Now let's zoom back out and talk about why any of this actually matters. I mean, really, why are we talking about a language that's from the 1970s?
You know, this quote really just nails it. C is foundational. It's like it established the rules of the road for what a modern programming language should even look like. Things like using curly brackets to group code, ending lines with semicolons, the way we structure loops, all of that was pretty much defined by C, and its influence is so profound that most modern languages you use today still follow that exact same blueprint.
And I promise you, this is not just a history lesson. C is everywhere, right now. The very core of Windows, Mac OS, and Linux, written in C. The compilers that we use to translate all those other newer languages, they're often built using C. And think about any device where raw performance and direct control over the hardware is absolutely critical. We're talking about the computer in your car, your microwave, even the freaking Mars rover. In those places, C is still the language of choice simply because it is incredibly fast and ridiculously efficient.
And you can really see that influence laid out here in this sort of family tree. C++, Java, C#, Python, JavaScript. I mean, these are the absolute titans of modern software development, and every single one of them stands on the shoulders of C. It's often said that learning C is like learning the Latin of programming. Once you understand it, you start to see its roots absolutely everywhere.
So let's put it all together. What is C? C is that essential bridge. It's the powerful, no-frills, super efficient language that takes our human ideas and translates them into the raw machine instructions that make our entire digital world possible. And that leaves us with a really fascinating question to think about. C has been the bedrock, the foundation, for 50 years. But as we look towards the future of computing, if all the tools we're using today are themselves built with C, what language are we going to use to build the tools of tomorrow?